Section 8.2 continued. Here we're going to talk about e, which is a constant, and it's an irrational number that approximates to 2.71828. Of course, that continues and never ends, and it's non-repeating. That's why it's irrational, very similar to our irrational number pi. Exponential functions with a base of e are useful for describing continuous growth or decay functions. Y equals e to the x. Here, b is e to the x. That's my exponential function. I have its ordered pairs. E to the 0 power is 1. Anything to the 0 power is 1. Then e to the first, 2.17828, which we have here. And then squared, e to the -1, -2. And then I've graphed the function y equals e to the x. We can see that the domain is x can be all real numbers, and my range is y, such that y is greater than 0. So I know that my asymptote is at y equals 0. Let's take a look at our first example. Here we want to use the graph of y equals e to the x to evaluate each expression to 4 decimal places. Here I want e to the 5th. So the first thing that we're going to need to do is to graph the function. So let's take a look at our graphing calculator. I'm going to press y equals to enter our exponential function. Our e for exponential function is at second ln on the left side, which is e to the x. And I'm going to plug in an x for my function, y equals e to the x. I'm going to graph. And we are in Zoom 6, so it's our standard graph. We don't need anything below our x-axis, so let's set our window a little bit better. I can have a y min at, let's say, a -2. And we can actually go up a little bit farther on our y max. Let's make this 20 just to get a better look. And let's change our scale to 2. Notice we have a difference here of 22, so we want something that multiplies unevenly. Let's pick 2. Let's regraph that, and there's a better look at my exponential function. Now, what we wanted to do was to calculate e to the 5th. So we can do that by looking at the graph. We could also look at a table by second table. Another way to do it is second trace, which actually is calculate, and we want to calculate a value. And since we already have in our graph y equals e to the x, I have to name what x is going to be. And we want x to be 5. And I press enter, and I get a value of 148.41316. Rounding to the 4th decimal place is going to give us 148.4132. Let's continue. We have e to 2e. And I want to press second trace, which is calculate a value again, number 1. And I have e to the x in for y. And all I need to do is pick out what my x is. And here it is 2e. So I'm going to press 2, second, ln, which is going to give me e. Now, it wants an exponent. But notice there's no exponent on this e. But there is. It's known to be 1. So I'm just going to place a 1 in for that exponent. And when I do, I get 229.65166, which is going to give us 229.6517. And this example, e to the -3/2. Again, I'm going to press second trace, which is calculate a value. And my x is going to be a -3/2. So here I have a -3 divided by 2. Enter, and I get a value of 0.22313. And when I round that to the fourth decimal place, it's 0.2231. You could also calculate these values by just going to second, E, or ln, and then placing the value that you want, which is here, for example, a -3/2. -3 divided by 2. And notice we get the same value. But I wanted to show you the actual graph and how to calculate values by using the second trace or calculate. On our last example, we want to find the amount that we have in an account that is a continuously compounded account for the given condition. So here's our formula. A stands for the amount I have at the end of time that is going to be given to us. Here, our time is 2.5 years. P is our principal, which is the amount of money that we start with, we place in our initial account. E is our exponential function, and here I have R, which is the interest rate for the year, and T, of course, we already stated is in years. So we have to calculate all of our time in terms of years if they give us months. So all we're going to do is substitute our values in for our variables. Here, I want to determine the amount. So I have my principal, which is my starting amount, which is $3,550. E, my interest rate is given, and I know I have to convert that to a decimal by dividing by 100, which is going to give us 0.073. And times that by the number of years that it's going to be in the account, which is 2.5 years in this situation. Now all we're going to do is plug this into a calculator, and then we'll determine the amount that is in our account after this given time period with this much invested with that interest rate. And from the calculator, I get $4,260 and a decimal of 0.7602. I want to round to the nearest hundredth, which is a penny, which would be 0.76. So our amount after 2.5 years, 7.3% interest rate, and beginning at $3,550 is $4,260.76.